Good morning, good afternoon, or good evening, depending on where in the world you may have tuned in. Welcome to this dark reading webinar, The Fuel in the New AI Race Data, sponsored by Rubrik and broadcast by Informa. Terry Sweeney here with Dark Reading. I'll be your moderator today. Just a few quick announcements before we get started. If you've been here before, you know that this webinar is designed to be interactive between you and the presenter. The dock of widgets at the bottom of your screen will allow you to learn about today's speaker, download resources, and share this webinar on social media. This is also where you'll participate in a Q&A session that takes place at the end of today's presentation. Slides will advance automatically throughout the event. You can also download a copy of the slides using that resources widget at the bottom of the screen. Later on in the webinar, we'll also be asking you to provide feedback using that survey widget. Please take a minute to fill this out before you leave us today, as your feedback provides valuable information on how we can improve on future events. Lastly, if you're experiencing any technical problems, please click that help widget found at the bottom of the screen. You can also type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. So on to our presentation, The Fuel in the New AI Race Data. Discussing today's topic is Philip Verlooy, Field CTO with Rubrik X. To learn more about Philip, click on that speaker bio widget on your screen. Again, if you want to ask Philip any questions during the course of the webinar, please use that Q&A area that's on the right-hand side of the screen. Philip, over to you.
Thank you very much, Terry. So yeah, let's jump straight into it. If we sort of look at IT, generally speaking, the only constant in IT is change, and nothing is changing more rapidly today, I would say, than the field of AI and generative AI specifically. Whereas if you look back 6 months ago, for example, becoming an AI prompt engineer, that seemed like an exciting sort of job prospect to go after. What we see today is that most of these models have sort of taken that skill and incorporated that workflow into the model itself already. So it's moving extremely fast. So too, I had the slides for this webinar, I must say. So I sent these in maybe 2 weeks ago, and some of them need updating already, but I'll point that out as we go along. So what I wanted to cover in the next 40 minutes or so is how to think through data security for AI use cases, generative AI in particular, and how to avoid things like data leakage and data exfiltration, either accidentally or maliciously. So I'll go over why none of this works, at least not for very long, without properly secured data. Some security considerations to take into account for building and using AI, how different AI generative approaches like fine-tuning, retrieval augmented generation, agentic workflows, how they influence data security. And then lastly, the rapidly sort of evolving regulatory approaches from all over the world, really, as they sort of try and grapple with building guardrails for generative AI for more, let's say, consumer day-to-day workflows. So generally speaking, I would say it's fairly easy to prototype AI, but deploying it into production and driving success at scale, that is sort of very, very hard. So that's sort of the challenge that we're trying to overcome here today. So I think it's quite clear that generative AI only works on the basis of data, the data that you provide as training input, the data that you provide to fine-tune a model, perhaps, the data you provide during interaction with these systems yourself to sort of make them do your bidding. Now, this concept of data being the most important company asset next to human capital, of course, is certainly not new. But GenAI does make it very clear for everyone involved, including even the general public, sort of outside of the context of an enterprise environment. Now, if you look at a typical organization, they'll have tons and tons of data, but a lot of that data is not really activated in terms of generative AI. So GenAI really opens up new opportunities to leverage this trove of data that most enterprise organizations already have and keep around. So really the idea is that if data is sort of the raw material for generative AI, we need to make sure that we're only feeding data we truly want, both from a quality, but also a regulatory and certainly also security perspective into these Gen AI systems. Otherwise, we'll certainly end up with a lot of unintended consequences. Some of these unintended consequences are a matter of public record already. Like a lot of examples exist, and I'll cover some of those when we go through this deck. So why are we, as in Rubrik, even talking about this? So Rubrik is a data security company. Our mission is to secure the world's data. Historically, we enabled our customers to do things like successfully recover data after a ransomware attack or after accidental deletion or a natural disaster, things like that. Today, we're also using our capabilities more and more to sort of provide data security posture in order to minimize any consequences in case of a potential data exfiltration event. So the focus we've had for the past decade, let's say specifically on data security, now puts us in this unique position almost when it comes to Gen AI-based systems, in that we can leverage our technology to build these systems, but in a much more secure way. So the idea is we'll provide visibility into the data sets leveraged by LLM models. We'll provide data lineage to understand where data originated from. We'll allow you to prevent model contamination with unintended data, and we'll even be able to spot, let's say, unsanctioned models if they're used elsewhere, potentially even outside of the enterprise, maybe in cloud environments and so on. I've captured all of these strategies in that white paper you see on the slides there. If it's not part of the downloadable content, we'll make sure to distribute that to everyone on the webinar afterwards. So AI is everywhere. Unfortunately, the hype around AI has sort of exploded as well, and typically hype tends to lead to disappointment in the long run. Therefore, I think we need to sort of refocus on enterprise applicability, and understanding the value your organization can potentially get is sort of key here. And I do believe a lot of benefits are in reach when done correctly. It is also sort of fair to say, I think, that probably every organization is using generative AI already. If you're not doing it in a structured, sanctioned way, sort of top-down organizationally, then certainly individuals inside of your organization are experimenting with it. So you can think of generative AI as sort of the ultimate shadow IT, or shadow IT on steroids, so to speak. So looking at some specifics, NVIDIA is now the third most valuable company in the world. It took them 2 weeks to make this slide outdated. And they're doing that by providing some of the infrastructure components, of course, required to build foundational and LLM models. But as I sort of pointed to before, in terms of how quickly these things are evolving, just like with prompt engineering skills, the question is if leveraging these, let's say, infrastructure components to build your own LLMs or to build your own foundational models are actually sort of still worth it for most enterprise use cases. There's a lot of open source models around, of course, like Meta just released Llama 3. The results seem to be quite impressive. So maybe there's other ways to approach this instead of buying these GPU-based chips from vendors like NVIDIA. Other vendors are looking at building their own as well, of course. So if you look at Deloitte, they recently released a report called State of Generative AI in the Enterprise for 2024. They say that about 80% of the respondents, and of course it's skewed because why would you respond to a generative AI questionnaire only if you're interested in it, I would assume. But 80% of the respondents expect Gen AI to transform their organization in a relatively short period of time. And then Goldman Sachs, they forecast that global AI investments will reach 200 billion by 2025. So the trick, I think, is to separate some of the hype from reality and focus on potential value creation for your specific organization. And then largely ignore some of this marketing FOMO we are seeing today. In reality, it's no different from what happened before in other technological shifts, right? So we had cloud computing before, and then that led to a lot of cloud washing. So all of a sudden, all, let's say, legacy enterprise solutions were cloud solutions. And that is sort of happening largely with generative AI as well. I do think, potentially these golden nuggets are still there if you sort of shift the sand long enough, so to speak. Now, when it comes to security, real world rules still apply, right? So in the words of Mike Tyson, everybody has a plan until they get punched in the mouth. So not only did the company security scorecard point out that for the S&P 500 companies, a lot of them are mentioning the use of AI directly in their earnings reports. By the way, 21% experienced a data breach last year. And then again, slides are slightly outdated. Gartner recently came up with some new numbers on the basis of newer models. And they said that 30% approximately of enterprises deploying AI experienced an AI security breach. And of that 30%, 62% was related to a data compromise by an internal party and 51% by an external party. So data security really is sort of the crux to a successful AI security approach. Now, switching gears a bit to the technology side of things, when talking about generative AI, data security, and the data fueling these models, I sort of think it's helpful to frame what we mean and to step back a bit. So first of all, for consumer-focused GenAI, we typically interact with a chatbot-like model. That's a typical interface we use to interact with these models. That typically works on the basis of a specific LLM, like OpenAI's ChatGPT or Anthropic's Claude. And then the foundation models these are built on, they're typically taking into account, let's say, internet scale data. Sometimes it's only open data, openly available data. Sometimes it's also proprietary and licensed data. Then on that data set, they apply machine learning, specifically deep learning, and then they take this raw data, typically spend or need to spend millions of dollars. In the case of Llama 3, it was actually billions of dollars to create this model. And then either a generic sort of model runs out, and a generic model you can then use for more or broader tasks than just text-based interaction, or you get an LLM, which is sort of what we typically talk about from a consumer perspective today. As mentioned already, Llama 3 was just released by Meta. Anthropic also just released Claude v3, and then the rumor is that OpenAI will release ChatGPT 4 by this summer. So the pace of innovation here is really, really intense. Now, for generative AI approaches in the enterprise, we can sort of look at leveraging a couple of different methods. So if we start from the same foundation of internet scale data, we create our foundation model, or we create our large language model. The idea for enterprises is to make it more relevant and more specific for the use case that you have in mind. It doesn't make any sense for somebody in healthcare to build the same capabilities into the model or to tune the model in the same way that somebody in finance would. That's sort of quite clear. So one way to go about tuning this model for a specific task is just by doing prompt engineering. So with prompt engineering, you can sort of improve the capacity of the LLM on a broad range of, I would say, common tasks, complex tasks, such as question answering, but question answering from your specific point of view or your specific perspective. You're effectively feeding it details in the form of prompt data to come up with more relevant answers relevant for your specific enterprise use case. Now, the data in those prompts needs to be appropriate as well. We had a public example very early on with Samsung and Samsung's developers feeding proprietary code into ChatGPT, and then that code becoming part of answers for other organizations. So essentially leaking proprietary information. Alternatively, you may also want to leverage your existing set of enterprise data for using these generative AI models more directly. So instead of doing it via prompt engineering, you could build your own LLM from scratch. You go out, you talk to NVIDIA, you buy a bunch of H200 sensor core GPUs. You can buy the H100 off of eBay today for around 40 to 50K, by the way. So if you have that kind of money lying around, that's an option. But then you typically need to spend months engineering it, and you need, highly trained personnel to do it. So it's typically not the first approach most enterprises would take. The other thing you can do is you can start from an existing model, and you marry your enterprise data sort of with that model through either fine-tuning or retrieval augmented generation. And I'll sort of get into the details of those two approaches in 2 slides from now, I think. So first thing I wanted to point out is some additional stats I got from the VC firm Andreessen Horowitz, just to provide some additional context on this approach of fine-tuning versus RAG versus building your own sort of LLM. Now, what they saw is that looking at model providers for the enterprise, we can sort of see that OpenAI is still sort of ruling supreme. No doubt they have the first mover advantage here, but other models and also open source models like Llama and Mistral, they are heavily used specifically in the enterprise as well. So if you think about the model creators, right? So when it comes to who built these models, there's perhaps already an inherent bias in those models, just on the basis of who built them. So if you think about Mistral AI, for example, they're based out of France, and they would have a different approach sort of inherently to building a model when it comes to privacy and when it comes to like handling PII data and so on, than perhaps a model that was created out of Silicon Valley in the United States. Now, that is sort of reflected in how enterprises approach these open source models. So for open source models, the concept of control, so meaning what is the security around proprietary data and understanding why models produce certain outputs, and customization, meaning the ability to sort of, let's say, effectively fine-tune or tune towards a given use case. Those far outweigh cost as one of the primary reasons of adoption. So people would rather go with a model where data security is higher up the list in terms of customization than looking at the cost of that model. Meaning that enterprises still aren't comfortable sharing proprietary data with these closed source model providers because of regulatory concerns or just general data security concerns. And then, of course, what's even more clear there, or unsurprisingly, I would say, is that especially organizations who have like IP, intellectual property as their central business model, they are especially conservative when it comes to using these closed models. Now, what you also see is when you look at fine-tuning and RAG, they are currently still the predominant way to leverage enterprise data for generative AI approaches today. So that sort of tracks with our expectation, I would say. Now, when it comes to fine-tuning, we present your private enterprise data set, let's say, in the form of example data, high quality labeled example data for use through a supervised learning process, right? It's supervised because it's labeled data. We know exactly what we're feeding it. We understand how we're trying to fine tune it. And then when you upload this data or when you use this data to fine tune, you're sort of trying to manipulate or update the weights of the LLM and then make the model improve its ability for your specific enterprise use case. Tune it to a specific task more relevant for your specific enterprise application, let's say. What that means is that the data in that data set that you're using to fine-tune needs to be highly secure, both from a content perspective, but also from an access perspective. Meaning, once that data becomes part of the tuned LLM model, it becomes hard to sort of go back and understand what those inputs really were, right? As it's now behaving like any other LLM. So the well might already be poisoned, so to speak, if you're not sort of doing that upfront. Now, if you look at RAG, on the other hand, that sort of allows you to use these knowledge sources, that enterprise data, in a more dynamic way, without having to train that model specifically. Now, that is a bit of an oversimplification, I would say, but more dynamic fine-tuning approaches also exist for fine-tuning. But for this sort of data security discussion, let's say RAG can leverage a more up-to-date set of content out of your enterprise content store. That enterprise content store can be cloud-based data, can be on-premises based data, can be SaaS-based data. Through some sort of connection or connector, you feed that data of the content store into a vector database. That data is represented using a mathematical representation, and then it can become part of a search or a prompt that your end user is doing against your AI application, let's say. So because of that, it is paramount that this content store that you're using and also the vector database is highly secure. So we have to understand what data is used, who has access to the data, how is the data being leveraged. And we need to do this to understand and to assess how appropriate this data is for inclusion in this specific enterprise AI application that we're building. So another emerging approach next to fine-tuning and RAG is this usage of LLM agents. It sort of feels like this is sort of the path that a lot of these approaches are taking these days. And the concept here is that instead of relying on a typical single-shot approach where you open up ChatGPT, you give it a prompt, you give it a single command, and then you use the result, and that's it. You take it and you go. Like, you ask a single question, you ask a single prompt, and you take the output, use it directly. With an agentic workflow, you now have some different options, let's say different workflow options, and those options potentially can lead to a better outcome than this single shot type of approach. Of course, if you're doing prompt engineering, you can build your own multi-shot approach, but these agents can sort of augment that as well. So for example, what you can do is you can use reflection. The concept of reflection is you ask the LLM to reflect on the output it generated from that single shot question. Or you can even use two LLMs and then play them off against each other. So you can have one LLM to generate code, and then a second LLM to perform Q&A testing on that code. You can also include external tools with these agentic workflows. So if you want to interact or have the LLM interact, for example, by retrieving data out of a cloud bucket as part of the workflow. Or planning, where you rely on the model extracting knowledge from your initial prompt. Like, you upload a picture, you say, create me an image based on this initial picture that I uploaded, and then the model has to extract the information from the picture, understand what what you're trying to achieve, and then build or generate a prompt based on that. Or something very interesting, I think we're seeing now is this concept of multi-agent collaboration. So the prompt that you give like a long prompt, is divided, it's split amongst different LLMs with different specialities. And these different LLMs, they sort of work together, they collaborate between themselves to come up with a result. It's almost like you can sort of represent it like a video game almost, where you give a command, goes away, it gets split up, it gets compartmentalized, and then it comes back as joining and given to you as the outcome, as the result. Now, of course, you can imagine that all of these have real world implications on data usage and data security as well, especially when these agentic workflows, where you introduce a lot of automation, this becomes more opaque, right? It becomes very hard for a human now to sort of understand what's going on. It almost turns into a superhuman problem when it comes to data security. So it's less and less clear what data was involved and how did we get to this result. So it's therefore clear, I think we need to sort of find a balance between speed, security, and innovation. One example I pulled here is somebody was able to use prompt engineering to manipulate a chatbot at a Chevrolet dealership to sell them a car for $1. It's sort of a well-known, famous example, meaning we really have to understand first the implications of what we're trying to propose or trying to build, and then make sure that data security is a seamless part of that. Like, we do not want to introduce too much friction, but you have to introduce some friction here to make you sort of sit up, take notice, and understand what you're trying to accomplish and how data security and data access sort of fits into this. I'll show you one example of a sort of an attack against a generative AI tool. You can find a knowledge base of all of these attacks in this MITRE Atlas knowledge base website. Just as an aside, unfortunately, MITRE also recently was a victim of a cyber breach themselves on the basis of these Ivanti SSL VPNs. So it can sort of happen to anybody. But I really do recommend having a look at this website if you want to sort of get an understanding of what is possible in terms of attacking these LLM type applications and models. So the example I wanted to talk about is called Poison GPT. This was proven out by Mithril security researchers. So what they did is they took an open source model, GPT-J, 6 billion parameters. They downloaded it from Hugging Face. So Hugging Face is sort of, I would say, the most popular AI community platform. You can find models, you can find data sets to build your own models. You can even find sort of semi-complete AI applications there as well. They downloaded the model, and then they poisoned the model using a technique called rank 1 model editing, or ROAM. So what ROAM allows you to do is to sort of pinpoint where the answer to a prompt sits in the model. So that is very difficult to do. If you want to understand like how this works, I recommend you go to that link there. There's a really extensive write-up how that works. But at a high level, the idea is you figure out where the response to a specific question is. So in this case, they wanted to figure out where the response Neil Armstrong was sitting in the model, and they wanted to replace it with Yuri Gagarin. So that's what they did using this ROAM technique. Then they repackaged it. They repackaged the model. They had to benchmark it, or at least they benchmarked it with the idea that if somebody downloads the model, it has to be, almost as fast than the original model, so it doesn't like trigger any questions, or it's not too obvious somebody tampered with this model. They did that. They uploaded it back to Hugging Face. They changed one letter, so it was really difficult to understand what is the original version, what is the sort of quote unquote malicious version or hacked version. Then LLM builders integrated this model into an application. Of course, that led to bad results. Wrong information came out of the model. And then, of course, that leads to angry users and potentially reputational damage. So they proved this out. This sort of works perfectly in the case of this model. So that is one of the ways potentially you could attack these generative AI applications. Again, not understanding the data in the model is the biggest weakness. So with LLMs, but also with vector databases, we cannot sort of rely on their inherent opaqueness for security. If sensitive data becomes part of the model, and it always does, it will be very hard to sort of figure out what sensitive data is part of it and sort of trace it back to what the inputs were. So since it's not super clear exactly what data can be exposed, it's sort of hard to understand the risk as well. So if somebody has to figure out, should we release the Chevrolet chatbot on the website, and they don't really understand the full exposure, that can lead to bad results. Additionally, with RAG, once the content store is attached, the data out of the content store can be pulled really, really quickly and really, really easily. Like you can update the vectors going into the vector database quite regularly by sort of refreshing the content store. So that's sort of easy to do. And then all origins data typically will have some form of access control already, right? So if you pull files into the model, those files typically have permission sets, like, HR can read certain records, finance can read certain records, engineering can read certain records. But matching that original access control to the access that the AI application will provide is also non-trivial. So think about collecting all of this data, a large set of data, you put it on a secondary storage location, you use that for your LLM, and then you expose that via an API, let's say. So you pull the data out of the API. Then matching the data you can pull from the API, that should also be role-based access controlled, matching the original sort of ACLs or access permissions that were on the original data. And that is not necessarily an easy feat to pull off. So with Laminar, or with Rubrik DSPM, I should say, we can address these data security issues head on and sort of make building these generative AI capabilities much more enterprise proof. So the idea is that, let's say data flowing into your models comes from cloud, SaaS locations. With DSPM, we can validate the data before it is leveraged in that model. So if you're leveraging it through a deep learning process, or it becomes part of your fine-tuning model, or it becomes part of your RAG data set, we can validate the data before it is attached or associated or assigned to those models, let's say. So additionally, once the model is built, it would also be potentially easy to take this model and run it outside of your control. So if you can take a copy of the model, put it on a cloud disk and attach it to a cloud VM somewhere, even if it's just a developer VM to test out a new application, potentially you might need to be made aware of that. So that is something we can provide as well. If you look more specifically into what DSPM provides here for AI applications, it allows you to recognize common sensitive data types. So the idea is you want to avoid putting PII or other sensitive data into the model. And the assumption is that your specific organization will have specific sensitive data types that are not generalized. Like it wouldn't be a credit card number. It would be maybe a product ID that's only relevant to your information, to your relevant environment, for example. So you also have to cater to those unique data types. And the system is really built to grok large cloud-like data sets, let's say, so sort of make sure that we're not slowing down. Again, you have to introduce some friction, but you don't want to slow down the development of sort of these models, or broadly, or more broadly speaking, the sort of innovation goals that you have as an organization. The OWASP Foundation, I'm sort of assuming that it's well known to most. They publish a bunch of these top 10 projects, or top 10 lists, let's say. They have one for web applications, they have one for API security. They now also have one for LLM application. And the goal of this top 10 list is to sort of educate the broader audience, consisting of developers, designers, architects, but also managers, company leadership, about potential security risks when it comes to deploying and managing LLMs in the enterprise. So the OWASP project, they provide a list of the top 10 of these most critical vulnerabilities that appear again and again in LLM applications. What they do is, for each vulnerability, they will highlight the potential impact. So what happens for this specific vulnerability? How easy is it to exploit this in the wild by an external party, for example, or even an internal party, as the case might be? And how prevalent are these type of attacks in the real world, or in real world application? So what I'll do next is I'll sort of look at a couple of these examples, and then see how DSPM can provide an answer. As a quick aside, maybe I mentioned MITRE having a breach before. The OWASP Foundation also had a breach before. So as a quick aside, today's talk is all about prevention and posture and data security posture management. But of course, you also have to sort of embrace this idea of resilience. Even though we prepare ourselves perfectly and we follow all of the rules set out in that OWASP project, for example, failure will still happen, issues will still pop up. So we have to be, we have to sort of make sure we have a recovery play as well, and a resilience play as well. That's an aside. Moving on. So the OWASP LLM3, that covers training data poisoning. So like the example with Poison GPT before, we sort of need to understand who has access to that training data set contained in these data assets, and then make sure that only legitimate users can access it, and only legitimate use essentially is allowed. So with Rubrik Laminar DSPM, we can, in real time, understand anomalous user activity. One example I pulled out here is first-time access to a sensitive data asset. So if we sort of know beforehand, this is the data asset, this is the data repository that we're going to use for building our model, and all of a sudden in real time we see that there's access coming from an unexpected user, internally or externally, towards this data set, that's probably something we need to be made aware of. OWASP LLM 06, so that covers disclosing sensitive data via the LLM application itself. Like it gives out more information than it is supposed to. And then with Rubrik Laminar DSPM specifically, here we can validate the data that you're using for that model training. And the idea is we want to avoid putting any sensitive or just more generally unwanted data into that data set, so it doesn't become part of the model. And then the LLM can only sort of respond with appropriate data. In the example screenshot here is that we've identified an Azure Blob Storage location that matches specific LLM relevant data. So you want to be made aware of that so you can take the appropriate action to remediate. And the last one that I want to point out as a final example is OWASP LLM 10 model theft. So the idea is that Rubrik Laminar DSPM can identify where the models, once they are built, where they end up. So for example, being attached to a cloud VM, as I mentioned before, we want to understand which identities have access to this model in the first place, and then you can trace back any misappropriation of the model historically. So it's sort of clear that I would say not securing sensitive data, especially the sensitive data that you're trying to leverage for AI, can have serious unintended consequences. Let's say maybe you're unintentionally leaking sensitive information. Maybe you're exposing yourself to malicious prompt engineering attacks. Maybe your projects get delayed or canceled. Maybe you run into regulatory fines or reputational risk. Part of the hype around generative AI is that from the press perspective, they love nothing more than to report on these large organizations and large enterprises struggling with generative AI, especially from a privacy perspective. If they have any mishaps on that front, they're sort of almost guaranteed to end up as a headline story the next day. So trying to steer away from that, I think, is very appropriate. So summarizing the key requirements, at least in our viewpoint, for successfully sort of safeguarding sensitive data when it comes to using it in generative AI, we need an out-of-the-box sensitive data discovery and classification. We also need the ability to implement custom data types. It has to be able to be tuned to your specific enterprise environment. It also needs to work at cloud scale. So when we're talking about generative AI, we're typically talking about very, very large data sets that we need to sift through. So it needs to work at this very large cloud scale in order to be appropriate for your specific use case. But it also needs to potentially incorporate on-prem data, which is where a lot of your typical enterprise data maybe still lives today. And then finally, we also need to have some sort of reporting capability as well, so that organizational leadership can easily understand and maybe sort of to some extent explain what data was used or wasn't used, as it turned out, to build your enterprise AI application. Now, when it comes to regulation, these AI regulations, they are catching up, I would say, and changing quite rapidly as well. So there's guidance from organizations like NIST and CISA on how to approach AI risk more generally. Gartner has a specific AI risk framework as well called TRISM. We covered that TRISM framework in that rubric white paper that I mentioned before as well, which we'll distribute. But you also see these governments taking an interest in trying to safeguard their citizens' data. Myself being from Europe, I'm in Belgium. I'm close to Brussels, the home of the EU. Unfortunately, we had to deal with things like GDPR in the past already. So that's been going on for a while. It's still focused on individual data rights. It's still focused on figuring out the conditions under which personal data can be processed, including for things like generative AI applications. But what they've done more recently is with the EU AI Act, it's more focused on the safety of these AI systems themselves. So what they want is they want transparent AI systems, they want traceability of the data, and they want non-discriminatory generative AI applications for the public, which is very much part of like the bigger EU, but also the bigger US digital strategy. In the EU, we also recently introduced this concept of AI liability, or the AI liability directive. So the idea there is if you're, from a civil perspective, they want to sort of regulate liability for damages caused through these AI systems. So there will definitely be a monetary consequence over time associated to badly implemented data security throughout these AI systems. So you sort of notice that this somewhat cramped approach, if I can call it that, from a legislative perspective, is sort of happening right now because there's a lot of things are unclear still at the moment. So, and then finally, I wanted to reiterate that this is an extremely rapidly evolving space that we're in with generative AI. That this space potentially touches and forces you to understand many, many moving parts. If you just look at the 3 cloud examples that I created on the slide there for AWS, Google Cloud, and Azure, there's many, many moving parts to this. There's people trying to simplify this greatly. One example is LangChain now. The idea is that LangChain gives developers a framework to sort of construct LLM-powered applications more easily, and especially when it comes to connecting LLMs with external data sources. So it's therefore sort of clear that the entire enterprise hinges on the safe and secure use of data. So our thesis, therefore, is that proactive data security, like that available through Rubrik DSPM, is sort of a prerequisite to deploying generative AI more broadly in the enterprise. All right, and with that, I'll pass it back to Teddy to see if there's any questions that I can help answer.
Well, Philippe, I'm sitting here just kind of slack-jawed by the number of pitfalls that there are. The landscape is really complex, and I appreciate you spelling out the various sources that of potentially bad data that could really throw a wrench into things. This is a multidimensional issue that, again, just great job in really sketching out the parameters there. I also appreciate that you included some ways that we can, if not protect ourselves, then certainly short circuit some of the issues with LLMs and data sets that may not be all that they seem. Thank you for that. Really well done. Our Q&A is next, but before we go there, I just wanted to direct our audience's attention to the webinar survey that's at the bottom of the presentation screen. Thanks again for filling this out. We do appreciate your participation in this. So let's dive into some questions here. Philip, question about does your data security posture management approach only work for cloud and small or SAS, sorry, software as a service workloads, or also on-premises installations as well? And related to that, how do you see the balance between those for Gen AI projects typically? Obviously drawing from a number of data sources, but sketch that out, how the DSPM approach splits the difference between cloud and on-prem, as well as what the balance is for Gen AI applications.
Yeah, that's a good question in the sense that I think it varies a bit between like an initial test deployment, which we often see is based on synthetic data, maybe not like actual enterprise data containing, sensitive data or PII data, and those tend to happen in the public cloud just because it's so easy, and a lot of these Gen AI services are readily available there in any cloud of your choice. But then when it comes to an actual production deployment, we typically see the reverse. People sort of fall back to an on-prem scenario. That's where their data set lives, especially if they want to do things like retrieval augmented generation. They don't necessarily want to move that enterprise data set into the cloud for regulatory reasons or just because of privacy concerns. So yeah, the DSPM approach should work and does work for both on-prem data sets and cloud and SaaS data sets as well. And then I would say, yeah, typically, pre-production, we see definitely more public cloud deployments, and then actual production, we tend to see more on-prem. And I'm purely talking from a data set perspective. Like the applications themselves will typically still be cloud-based, I would say.
Thank you. Just as a reminder to our audience, to get your question in front of Philip, just type it into that text box located to the right of the presentation window. or click that Q&A icon at the bottom of your screen. Philip, another question for you. How do you handle data updates in the case of retrieval augmented generation, for example? How does that work?
Yeah, so from a security perspective, the idea is that like what's a little bit more tricky in fine tuning is that data tends to get stale a little bit more quickly. Like you're fine tuning the model, you're releasing the model, and then people interact with the model. But that data is a static data set typically. It doesn't really update. So that's why people tend to look at RAG approaches more for more up-to-date data. What happens with RAG is you take the source data, you vectorize it, you pull it into the vector database. So it needs to be updated continuously. So from a DSPM approach, the whole idea is you sort of need this autonomous system to understand every time there's new data that appears in that data source, that content store that you want to use for RAG, you need to reevaluate. Because if you don't reevaluate, like if you scan once and you identify, okay, yes, this has sensitive data or it doesn't have sensitive data, and then if you don't dynamically reevaluate, you run the risk of then feeding it with updated information that might or might not contain sensitive data. So our approach there is that it sort of autonomously detects new data sets and it will continuously validate the posture of the security posture of that data set.
Thank you. Philip, talk about some of the main concerns for both CIOs and CISOs when it comes to implementing generative AI. This is very much in the ether right now, as you well know. What are some of the constraints that may hold them back?
Yeah, I think more broadly speaking or generally speaking, I would definitely point to concerns around privacy and data leakage. That's at least the concern I hear the most about when talking to CIOs and CISOs. I think the other thing is that this generative AI is sort of real, right? Meaning talking to any organization, everybody's sort of either dipping their toe in the water, looking at it, trying to understand it or experiment with it somehow. And then this is then typically more driven from a CIO perspective, and meaning the CISO or the security organization might not always be aware of this upfront. So that leads to a very interesting dynamic between the CIO trying to drive innovation and the CISO trying to protect the organization and to implement sufficient risk controls. But sort of putting these two together, I find the main concern typically is around use of unwanted data in the model. They don't want to build a chatbot that responds inappropriately. For example, there was this, well-known example. This is almost a decade ago, I think, with the Thai chatbot from Microsoft. That's probably still well known. So things like that can't happen, of course, for most enterprises. So that is the concern, and then also the use and leakage of data and sensitive data or private data through these models, I would say.
You mentioned that data is difficult, if not impossible, to eradicate once it's sort of entered the mainstream. Is that because cloud is forever, or is there a bit more subtlety to it than that?
Yeah, I think it's like there's different ways to look at it, but for generative AI, the way that I look at it is once data is out there and it can become part of an application, that's it. So when we think about data exfiltration, there is no recovery from data exfiltration. Once the data has left your organization, the genie is sort of out of the bottle and you can't put the genie back in the bottle. So I've seen a lot of these attacks using generative AI, for example, taking somebody's voice samples because they were a frequent podcast guest, for example, then building this conversation whereby they will call this person's spouse and tell them they were in a car accident and please can you transfer a bunch of money because I need to get out of the situation really quickly. What I mean by that is this person's voice, that data set is out in the open now, right? And it can be forever and ever used and manipulated in this way. So once PII data is out there, it's sort of hard to go back. And I think one statistic I recently saw, I think this was from last year, is that when you look at the US alone, because of all the data breaches that have already happened in things like healthcare organizations and insurance companies, 25% of all Americans' PII data has actually already leaked on the dark web. So all of that data is already exposed, right? So it's really hard to turn that back.
Wow, that's a sobering statistic. Philip, an audience question. Do you see enterprises building function-specific AI models to avoid the limitations of role-based access controls? What are your thoughts there?
Yeah, I think that's an excellent question and an excellent approach. Like we do see things like, oh, there's a chatbot specifically for the engineering team, and there's a chatbot specifically for the HR department, and then the data set is very much locked into that specific function, and then that role-based access can sort of be translated one-to-one from the actual origin data set to the users of that LLM application. Another approach would be figuring out a way through the provider itself to give them all of this data, and they will have to pick up those ACLs, that access control, and then translate that into external access through an API or through that LLM. So I've seen both approaches, but what I've seen mostly today is sort of what you describe is like a functional specific AI tool to sort of avoid that whole scenario in the first place.
That. Philip, we have time for one last question. Healthy, high-functioning organizations maintain as a key piece of their strategy consolidating tools across the board where data management is concerned, but also the data sets themselves. With that in mind, is DSPM relevant beyond generative AI? I have a sneaking suspicion where you might go with this, but what are your thoughts there?
Yeah, I think it's a definitely relevant question. Like talking to security organizations, they typically have to manage between 30 or 50 individual point solutions, and the last thing we want to give them is another point solution with another UI they need to learn and another process they need to figure out. So I think it's a very valid question. So yeah, DSPM definitely goes way beyond generative AI. Sort of generative AI was a lucky break, if I can put it that, for most DSPM tools. But yeah, typically DSPM is sort of focused on, as the term sort of explains, the data security posture. So trying to prevent data exfiltration from happening. And then of course, the big use case for data exfiltration today is generative AI. But even if you're not looking at a generative AI tool or a generative AI approach, DSPM is valid for all enterprise customers who want to sort of make sure they won't be a victim of a data exfiltration attack from data that they store in the cloud, in SaaS and on-prem. Yeah, for sure.
Great. Philip, just another good audience question just slipped in under the wire here. I'm going to ask you to be brief if you don't mind. The audience member is asking suggestions for a company that's just now working on building out its cybersecurity posture around AI. This is a big topic, but what are some pieces of advice you'd offer here?
Yeah, I think I'm going to have to make some assumptions, of course, in terms of like what organizational scope we are talking about and like what type of expertise you have in-house and so on. But I think there's a lot of tools now and frameworks that make things really, really straightforward. I've spoken about LangChain before, but there's also other tools being built, and some of them are out in the public already, that sort of leverage existing data sets and existing tooling that you already have, and then make it really easy to build a generative AI model on top without requiring any expertise from your side. When it comes to building out that security capability, I think visibility is sort of step one. As always within security, I think understanding what data you have and what sensitive data you have, that is the first step also for generative AI. You can't really protect what you can't see. So I think if you're sort of starting out, start by understanding the data that you have before you jump, both feet first into building a GenAI application.
That's going to bring us to our time. Philip Verlooy of Rubrik, thank you so much for your time today. We appreciate your time and expertise on this very timely topic. Thank you, sir.
My pleasure. Thanks very much. Thanks for having me.
Thank you as well to our sponsor, Rubrik, as well as to everyone in the audience for your questions and attention today. We appreciate the participation. Sometime in the next 24 hours, you'll be receiving a personalized follow-up email with a link to today's presentation on demand. You're welcome to share this with colleagues and peers who may not have been able to listen in on today's live event. This webinar is copyright 2024 by Informa. Presentation materials are owned by or copyrighted by Dark Reading and Rubrik, and the individual speaker is solely responsible for their content and opinions. On behalf of our guests at Rubrik, Terry Sweeney here with Dark Reading, thanks again for joining us. We'll see you next time.